Okay, so this is going to be 1.1 continued. So kind of piggybacking off of what we just got done doing, we were talking about slopes and slope, not slope, intercept. We were talking about slopes and point slope form. So then today we're going to start talking instead about slope intercept form. So basically the exact super similar to that point slope form where you needed a point and the slope. Instead now we're dealing with a slope and a y-intercept. Okay, so in this equation, y equals mx plus b. The m is going to be the slope. The b is going to be the y-intercept. Okay, so we're going to start right away off with an example. We want to determine the slope and the y-intercept of the linear function. So step one, in order to do so, we need to get it into the slope-intercept form. What that looks like is a y being isolated on this left side with the mx plus b or anything else on that right side. So we're going to take this equation, bring it over here. The first thing I see that's kind of inhibiting me from having just the y alone isolated on that left side is my x's, okay? So I want to deal with everything else first and then finally deal with my y. So I first want to get rid of this 4x. In order to do that, we need to subtract off 4x from both sides. This is going to cancel out, leaving me with negative 3y equals negative 4x plus 9. Okay, so now that I've gotten everything else cleared out, I can deal with this negative 3y. Keep in mind, for y equals mx plus b form, that y is positive, right? This y here is positive. So I also need my y here to be positive. So when something is multiplied by a variable, in order to get rid of it, you do the opposite. Right now it's being multiplied by, so I need to divide by it. Divide 3 by 3, I'm going to get rid of that 3, but not only 3, it needs to be a negative so that the negatives cancel out. Leave me with y equals, over on this side, negative 4x divided by negative 3, negative divided by a negative. That turns it positive, but I can't divide out that fraction, so it's going to remain 4x over 3. Over here, positive 9 divided by negative 3. That does divide out evenly, but it's going to divide out as a negative. 9 divided by negative 3 is negative 3. So I'm in my slope-intercept form, but I'm not quite done yet. I still need to do some identifying. So I've got almost to the point that I need to be, but I just have about one more step. Looking at the information that I have up here, okay, I'm saying that the m in y equals mx plus b is my slope. So the m right here is right out in front of that x, so 4/3. So my m, or slope, in this case, is that positive 4/3, okay? Last thing is my y-intercept. So I'm trying to identify my y-intercept. One thing I want to know about a y-intercept, if I'm crossing, let me make this over here. If I'm crossing anywhere along that y-axis, okay? If I cross here, if it's here, or all the way down here, one thing stays true. X along this entire y-axis is always going to be 0, okay? So it's always 0y. So when I write my intercept, I want to actually write this as if it's a coordinate point. That x value should always be 0 for that x coordinate, right? Because we're along that x-axis. So then if we look out, this plus b is where we're dealing with the actual intercept. So that is going to be negative 3. One thing to remain certain of is that you bring this sign with it, right? So if it's negative, I take the negative. If it's positive, then it's a positive. But it is in fact negative 3 as that intercept. Okay, so that's that part. All right. So I have one more example. It's going to be a long one because it's going to be a multi-part one. Just a warning. Two things we need to talk about before. One is parallel lines. Let me make sure I'm not spelling that right at all. All right. So something we know about parallel lines is obviously they go together, okay? They are equidistant. They will always have the exact amount of distance in between them. That stays constant. They will never cross. If this is true, they have to be going up and over at the exact same rate. That being said, two parallel lines must have the same slope. So if I call this M1 and that, let's say not M1, let's say L1 for line 1 and line 2, okay? Basically, their slopes must be equal. Sometimes people get a little bit too tricked up in like the notation of things. And when they see this, they might say like, well, I have no idea what that means. It truly means that their slopes are equal. So on the other side of this, we also deal with perpendicular lines. Okay, so what that is when two lines meet at an exact right angle. So if you can tell, I'm going up and over at the exact same rate. Basically here, we're going up and over at the exact opposite rate, okay? If you even kind of maybe tilted this, it might be a better description because right now this is looking just like an undefined slope, but that's not the case, right? So if we kind of tilted that, you could see that they're going to be having exact opposite slopes. So what this looks like more notation-wise is, let's call this L1 and L2. The slope of my first line, okay, is going to be that M1. What happens is we are literally the exact opposite. So not only are we negative in the second slope, we also are now in the bottom of that fraction. So what this is, and if any of you guys had Mr. Gale for math, you would have known he liked to use the gang signs. Basically, he said if you have a perpendicular line, you're supposed to flip it and add the negative, okay? So a little gang sign to help you remember. If you didn't have Mr. Gale, you might not get it, but that's the kind of thought process behind that. We're gonna do two, and you can do the notation for that if you'd like. We're gonna do an example where we write the line of a parallel line and a perpendicular. So using the same example for both of these. Okay. So I want us to find, can you see that high? Yeah, you can. Find the equation of the line passing through the point to -1 that is one parallel to perpendicular to 2x minus 3y equals 5. Okay, so basically what I'm trying to do is not make us have to redo the same kind of example twice. So I'm going to have two different case scenarios. Okay, in the first one, we're going to find the line that's parallel to this line. In the second case, we're going to find the line that's perpendicular. Okay, so let's work on one right now. First step that I want to do is I want to put this into slope-intercept form. So that's what we just got done doing, okay? We have to take this line, this equation of the line for 2x minus 3y equals 5, and we have to isolate the y. First, we're going to do that by getting rid of these x's. Okay, right, just isolating the y here. So first we get rid of those, that 2x, we had to subtract that off. Now we need to divide out this -3. Okay, same thing as last time. To get y equals positive 2/3 x minus 5/3. If we pick out what we need, that is the slope. Okay, why am I trying to put this in a slope-intercept form? If I need to be able to write a parallel and perpendicular line, we just learned that that's all about slopes. So if I don't know the slope of the original line, I won't be able to find a line that's parallel to it or a line that's perpendicular to it, okay? That's why we're doing this, step 1. So the original slope, M1, right, is 2/3. Okay, so we're going to take that information. Remember, we're working on the parallel line right now. We're going to take all that information over here. All right, so slope is 2/3. So what I'm going to do with that is figure out what is a slope that's parallel to that. Okay, again, working on, can you see? Nope, you cannot. Right here. Kind of one continued. Okay, working on finding a slope that would be parallel to that. If for parallel, M1 has to equal M2, then if M1 equals 2/3, my M2, or my parallel slope, would also equal 2/3. Okay, that's going to be my slope. Again, that slope cannot change. So we're going to use something that we learned last time. That was point slope form. Why am I using that? So my goal is still to write that parallel line. So my line has to be parallel to this line. That's being done by using the same slope. Okay, this parallel part is now met. I'm making sure that it's parallel by using this 2/3 slope. But now I have a slope, and if I go back to my original directions, okay, do you see an intercept in there? The answer should be no. What I do see is that I'm given a point. So when I have a point and a slope, I have to use point slope form. Okay, point slope form was y minus y1 equals m x minus x1. If we continue filling this out with the information that we know, that's going to be the point from up top to -1, right, this point up here, to -1. So y minus y1 from up top, and that this is y1, this is x1. Okay, so back down here, y minus -1, 2 negatives there, equals my slope, my parallel slope here is 2/3, times x minus my x1, that was 2. Okay, so I got all the pieces together. The last thing I need to do is simplify like we've done before. Again, we're still working on a parallel line. Double negative here, subtracting a negative makes a positive. So we have y plus 1 equals, let's do this distribution in this step as well, okay? 2/3 times x is 2/3 x, or you can do 2x over 3, whatever is more comfortable for you. So now I'm going to go ahead and make this a negative already because I have a positive times a negative, which makes a negative. Now we're dealing with multiplying a fraction by a whole number. If we write this out, it's 2/3 times 2. Or when you think about any whole number, it's like writing it over 1. So we're kind of multiplying this by 2/1. When we multiply fractions, we multiply straight across. So if we rewrite this again, y plus 1 equals 2/3 x minus, when we multiply straight across, it's 2 times 2, which is 4, 3 times 1, which is 3. Okay, my very, very, very last step. I need to get y by itself, okay, back into that y-intercept form. So this is y equals 2/3 x. Now when we're subtracting 1 from this improper fraction, be really careful. Okay, if you need to go back and make like that kind of common denominator, you can. Just keep in mind when we're subtracting this, sorry, my knees hurt bad. When we're trying to subtract that off, we are taking this, we're already at -4/3. Okay, if you rewrote this as a common denominator, it'd be 3/3. So you're taking -4/3, subtracting -3/3. That gets us down to -7/3. Okay, that is our parallel, okay? Still, that's our number 1 answer. This is our parallel slope. I'm done with that one now. Okay, so now let's switch gears. Let's move this back over here. And let's switch gears just a little bit. Because now we're on to number 2, the perpendicular part of it. Okay, the perpendicular part. So let's recall when we put this into point slope form over here, the object of that was to find the slope of our original line. We did that, M1. The M1 was 2/3. Okay, so when we deal with perpendicular lines, we do something where we take the first slope, we write it negative, and then we flip it. So when we're doing this, we take this 2/3 and we say, okay, it's negative, and now it's written over 1. So this is, oh, that's a really big negative sign. So this is obviously not the form we're going to leave it in, okay? What we have to do is basically dividing by a fraction is the same thing as multiplying by the reciprocal. So this works out to be -1 times 3/2. Okay, multiply straight across. This is -3/2. This is the long way of going about it. A lot of you are going to ask me, well, can't you really just take that original fraction, flip it, add the negative? That's exactly what you can do. Like, that's the whole point of the little gang sign thing. But I want you to understand what happened behind this was that we took it over 1, right? 1 over the slope. Because we divided by a fraction, we multiplied by the reciprocal to get this -3/2. I just want to make sure you understand the math behind that. Now that we've gotten rid of that, we're good. So we've got our M2, right? This is my second slope. So now I have to do what I did before. I have my point. If you go back to our original problem, we have a point. Now we have a slope. Let's again use point slope form with our new slope, that same point. So y minus my y1, -1, equals my new slope, -3/2 times x minus x1, which was 2. All right. Again, subtracting a negative is the same thing as adding a positive. This is y plus 1 equals, let's distribute this out, -3/2 times x, -3/2 x, or again, you can do that -3x over 2, whatever's most comfortable for you. Now we're distributing a negative times a negative. So I already know that this is going to turn positive. Okay, that's one thing I can already put out there. We again are multiplying a fraction by a whole number. Again, you can write any whole number over 1. So this is the same thing as saying 3/2 times 2 over 1. Again, we multiply straight across. So y plus 1 equals negative 3/2 x plus 3 times 2 is 6. 2 times 1 is 2. So now 2 things can happen here. One, I do still need to get rid of this 1. We'll do that in a minute. But I'm going to simplify this fraction. Can we all agree that 6 over 2 can be simplified? The answer is yes, because 2 can go into 6 evenly. So y plus 1 equals negative 3/2 x plus 6 divided by 2 is 3. So my very, very, very last step here is going to be getting this y down to be isolated. So subtract 1, y equals negative 3/2 x plus 2. So that is my answer for number 2. Okay, we did number 1, we found the parallel line. We did number 2, we found the perpendicular line. Generally, you don't have to do both of those things at once. What I wanted to do was save us some time in finding that original slope twice. And hopefully I didn't go super long with my video. That was the whole point of that. I tried to put as many examples into one as I possibly could. Again, homework will be posted. In-person learners, please don't do it until we come into class. And remote learners, please go ahead and get that done. Okay. That's it for that one.